You are now on level 2 of stoichiometry. In this video, we're going to be figuring out how to convert between grams of one substance into moles of another substance. So you've done grams of the same substance into moles of that same substance before, but you have not yet done from grams of one substance into moles of one substance. There are two paths we can go on. If our given is grams of A, grams of our first substance, and our unknown is moles of B, so we're going from grams of our first substance into moles of our second substance, we will start with grams of our first substance, convert it in moles of our first substance, so this will use molar mass, our standard gram to mole calculation, conversion. And then we'll go from moles of A into moles of B, and this is using our molar ratio. This is what we learned last class. This is the ratio determined by the chemical equation. The other option is if we're given moles of A, so not grams, but moles of A, and we're converting into grams of B. So now we're starting with moles of A, and we're converting it into moles of B. So first we would use our mole ratio, and then we are converting from moles of B into grams of B. So now we'd use our molar mass. Okay, please be looking at your worksheet and doing this alongside me. So the first example says, for this reaction, and I have balanced it for you, how many moles of aluminum oxide, so that's our unknown, will be formed from 12.1 grams of oxygen. Okay, so our given in this case is our oxygen, our moles of aluminum is our unknown. We are going to use path 1, that's going from the grams of oxygen into moles of oxygen. Oxygen will be our A, into moles of aluminum oxide. Aluminum oxide will be our B. So we start with what we're given. That's the 12.1 grams of oxygen. And to convert from grams of oxygen into moles of oxygen, we do 1 mole of oxygen divided by the molar mass of oxygen. Make sure that when you calculate this molar mass, you do 2 oxygens. We have 2 oxygens. It's not just 1 oxygen atom. So at this point, notice our grams of oxygen cancel out, and we're at moles of oxygen. So now we're going to convert from moles of oxygen into moles of aluminum oxide, which is what we want to figure out. So our mole-to-mole ratio, if you look at that chemical reaction, for every 3 moles of O2, we will produce 2 moles of aluminum oxide. So for every 3 moles of O2, we're going to produce 2 moles of aluminum oxide. Our moles of oxygen cancel out, and we are left with moles of aluminum oxide. After multiplying across, you should get 0.252 moles of aluminum oxide. At this point, please pause the video and try 1B on your own. If you think you got it, you can fast forward to the end of this video where the answer will be. So 1B says how many grams of oxygen are needed to react with 1.25 moles of aluminum. So in this problem, our given is our moles of aluminum, and our unknown is our grams of oxygen. So we're going to be using path 2, where we go from moles of A into moles of B, and then into grams of B. Okay, so we start with what our given is, 1.25 moles of aluminum. Okay, if moles of aluminum is on top, in order to cancel it out, it must go on bottom. So our moles of aluminum will cancel out. And we are converting from moles of aluminum into moles of oxygen. So now we need to figure out how many moles of aluminum For how many moles of oxygen? Well, again, just look at our chemical equation and we'll see, oh, here's aluminum, here's oxygen. For every 4 moles of aluminum, we have 3 moles of oxygen. So we'll have 3 moles of oxygen per 4 moles of aluminum. And now we need our moles of oxygen to go on bottom. So that way we can cancel out our moles of oxygen. And we are converting it into grams of oxygen. Okay, so 1 mole, again, that's 32 grams because we have O2. So again, we just do our math, plug it into your calculator, and you should get 30 grams of oxygen. Please make sure that you have units and substance. You need both of those things. And I hope this helps. Please continue working on this worksheet and let me know if you have questions.